Greetings, you are once again welcome to my channel here of Today we are going to look at a further mathematics topic, quadratic functions. So we are going to use the method of computing squares to solve quadratic equations of this form. So before we start, don't forget to subscribe if you have not done that. You can also share, like our videos, and interact with us in the comment section, right? So let's go. Quadratic functions. Good. Now they are this form: ax squared plus bx plus c. That's what you see here. So this can be a, this can be b, and this is c. Why do we call a b c, right? Okay. So a b c, they are constants. They are numbers. And there is the real constant, right? But these are numbers to be determined, right? Good. As you can see here. Good. So if you remember in the other video that we did, right, we code quadratic trinomials. We use a very simple method to decode this or break this. Now they are asking us to use the method of computing squares. If you use that method, you can never get your maximum value from that method. You can only get a maximum and minimum value when you are using the computing squares method. So that is what we are going to do, right? So how to find the maximum and minimum values of a quadratic function using the method of computing squares. They are specific here. Now, so if f of x equals this, so I'm going to change this function to look like this. I'm going to show you how to do it, right? R squared plus c. Then c is the minimum or maximum value. So when you convert your equation to look like this c here happens to be your minimum value. The same c here happens to be your maximum value. What does it mean? It means this can be a minimum curve in case we are plotting. This can also be a maximum curve. So what is the minimum value of this? It means it is a minimum curve. So they will never ask you to find a. What is the maximum value of this? This is a maximum curve. You see, they never ask you to find a minimum. Good. If it is a minimum, they will also ask you to find a minimum, not the maximum. That's why they say c can be the minimum or the maximum value here. And this thing that you see here is the equation of symmetry. Right? The symmetry divides the curve, right? That's symmetry. You have a curve like this. That is the equation of the line of symmetry, right? So if here is 1, it means the equation is x equals 1, right? It means at point 1, right, divides the curve without symmetry. And the function occurs at this, right? Okay, so let's look at it. Say, and what is the value of x does it occur? So that's what I'm going to look at, right? Okay, so to start with, let's go. So you watch me. When I finish, transfer. Okay. I have 3x squared minus 2x plus 1. If I have to be using any quadratic method, I'll have used the trinomial method, right? I know, completing squares. Take notes. Now, the first thing to do is to make the coefficient of this x squared 1. What is the coefficient? Look at this. This is y. This is 4. The figure just beside the y is called a coefficient of y. Are you okay? That's what we call coefficient. So what is the coefficient of x squared here? It's 3. Okay. So the first thing is what? Make coefficient of x squared 1. So I take the 3 out. Now, what am I doing here? I'm making the coefficient of x squared 1. And what is the meaning of this? I've factored the 3 out. So I've divided 2 by 3. So that is it, right? So that is it. So is the coefficient of x squared 1? The answer is a big yes. Right? The answer is what? A big yes. You can see the coefficient of x squared is what? It's 1. So that is how to do it. Right? So if you factor the 3 out, it's just as if you are dividing 2 by 3. You see? Good. So that is it. I get 1 x squared. Now the next. So these are the points to guide you when you are using the complete squares method, right? Next, what you do is that this is the coefficient of x, 2 over negative 2 over 3. Good. Now, take half of the coefficient of x squared, no, of x. Take half of the coefficient of x. So, let me have the coefficient of x, add and subtract the half of the coefficients of x. So what is my coefficient of x? That's the first thing. So this is my coefficient of x. So half of x. So you have minus 2 over 3. That's the coefficient of x. How do you take half? Just multiply this number by that. You get a half of that. Let's go. 1 over 3. So you punch a calculator. Just punch half times negative 2 over 3. You get 1 over 3, right? So negative 1 over 3, right? Thank you. Negative 1 over 3. So take half of the coefficient of x. That is a half of it, right? There's an add and subtract the squares. It will add and subtract the squares of the half of the coefficient of x, right? So here, subtract the squares. Let me right here. Okay. Subtract the squares of the coefficient of x. That's it, right? Good. So you first make the coefficient of x 1. That is what happened here. Factor the 3 out. Now what if it is just 1 here? It's already 1. So you can't do anything again, right? Just go ahead, right? So I've done that. You can see it is 1. By taking the 3 out, that's as if I divide 2 by 3, right? As you can see here. And next one. Take half of the coefficient of x. That is it. Add and subtract the squares of the coefficient of x, right? The squares of the coefficient of x. That's a half of the coefficient. That's it, right? Good. The expressions are becoming plenty, right? The squares, let me qualify it here, of the half. Good. The squares of the half of the coefficient of x. So how do I do that here? So let's go. I have 3 here. That is 1x, so it's 1. And then we ignore s. The rule is that I add the square of that, right? This way. It follows that I should subtract the square of that again. That's the rule, right? Good. Square plus this constant here. Now when it gets here, you have to enter. So look at it again. So take the half of the coefficient of x. That is negative 1 over 3. Add the square of that. I did that. Subtract the square of that. That's what you see, right? Good. So whatever we are doing here is equal to what you see. So you have this. Now x squared. So this is a square, this is a square. I can put them together in this way. I can put them together like this. 1 over 9 all squared. Or you wish I do this? No. That'll be 1 over 3, right? This way, all squared, right? Good. Now, minus. Now, 1 over 3 all squared. This will be what? 1 over what? 9. The negative will disappear because when you square a negative number, the negative sign disappears, okay? So what is this doing here? This is that. This negative sign has disappeared, okay? That's what I had 1 over 9 plus 1 over 3. That is it. So you see, this is a completing square bracket. It's almost like this, as you can see, right? And just if you put the c together, this and this, it becomes something like this. So that is what we are getting, right? Good. So I have to multiply 2 by what? 3. As you see, this is 2 over 9 by 3. So I'll get 3 here. So this is minus 2 over what? 3. Good. So your maximum value, that's the maximum, right? Happens to be what? Negative 2 over 3. And it occurs as x minus 1 over 3 all equal to 0. X equals positive 1 over what? 3. So that is what we are getting, right? So don't forget, when you finish, you have to run the 3 through, right? So that you come there.